And the SAMR model links how you use a technology to the outcomes for students. If you use a technology at what is called the substitution level, so that you're essentially using it to replace an older technology and doing exactly the same sort of things that you were doing in your classroom before with the old technology, well, this may be useful. It may set the stage for future developments, but it will not in any way, shape, or form significantly impact student outcomes. A second tier is then the augmentation tier. And in the augmentation tier, now we start to say, well, can we at least use the technology to enhance how the students were carrying out tasks in the past before? So that now we're not saying that they're carrying them out exactly the same way they were doing them before. Now they're using certain features of the technology to make the task be accomplished in a more efficient fashion, in perhaps a more informative fashion for the student, in a swifter fashion, but overall the task remains the same. This will introduce small, noticeable, but still small improvements for students. The next level is the modification level. At the modification level, we start to say, well, wait a second. I'm sure that there were educational goals that you always wanted to attempt, accomplish, reach with your students that you couldn't have before. Now we can use the technology to modify the tasks that you were doing before with the student so that now they're at heart, the heart of the task remains the same. But important aspects have been modified so that the student can accomplish new goals that they could not have accomplished before. If the task before was, say, to write an essay individually, now we might be talking about writing an essay that is jointly critiqued by an audience of the student peers, so that they get feedback in ways they couldn't have before with edit cycles that are richer than what they had before. Or before, if they were doing set mathematical problems, now we're talking about using tools that allow the students to still tackle set mathematical problems, but get into reaches of math that would previously have been considered too complex for them to tackle, where the computer can handle some of the pencil pushing that's difficult or impossible for the student to do. At this level, we see significant improvements in student outcomes, the sort of things that you want your students to do. But we can go a level further. We can go a step further. And that step further is the redefinition level. And at the redefinition level, what we have now is what happens when we say, well, what happens if we replace part or all of the old tasks with new tasks that are uniquely made possible by the new technology that allow us to accomplish educational, pedagogical goals that we never could have before, we never thought we would be able to reach before. So maybe now we take that essay we were writing before, and now we say, well, I'd like the students instead to tackle conveying deep analytical thought in other media. So now perhaps they're doing digital video storytelling as their way of responding to a piece instead of writing an essay. And furthermore, they could become mentors to other students, because if I put a certain criterion of quality on these pieces that the students are producing, well, they could form the background for other students to learn from them. So we start reaching into new areas, new domains that we couldn't have reached before. At this level, the redefinition level, we start to see dramatic improvements in student outcomes. This is the level at which your students who were failing are now successful. And your students who were already successful are going places you've never seen students go before. In addition to the SAMR model, there are two more models that I find useful. One of them, the TPACK model, was developed by Mishra and Kohler. And the TPACK model says something very profound. It says, when you look at using technology in education, you cannot prioritize just the content knowledge, or just the pedagogy, or just, for that matter, the technology. You have to think of all three at the same time and as peers to each other. So when you're designing a unit of instruction, it's not good enough to say, well, okay, I'll figure out what the content is that I want to teach, and then after that, I'll go ahead and I'll fill in the blanks with a little pedagogy, and I'll see what technology I can bring along. Rather, you want to be thinking in an organic fashion as to how all three of these will integrate. And you want to think of these as peers to each other. You cannot think of one as less important or just accidental to the others. The third model is a model I don't quite have a name for yet. It's a model that says, well, based upon the research that was carried out by the Horizon Project Report Group over the past decade, it's possible to extract 5 major categories that help teachers decide what technologies to use and how to use them for what purposes. So the 5 categories are the social. Here are tools like blogs, wikis, all the tools that we use to share things, create things jointly, and share what we created jointly. Things like YouTube and Flickr also belong here, as do tools like Facebook and Twitter. Next, we have the category of the mobile. The devices we're using are intrinsically mobile, and in addition to that, the software that runs on them can make use of this fact to make things work better in terms of providing students with information that is relevant to where they are in the world. Information that says, because you're here, this matters to you. The next category then is visualization. Visualization here is any tool that can be used to take something that's abstract and make it concrete in 2 or 3 dimensions for a student to look at and better comprehend. So as I mentioned before, this includes maps, it includes timelines. It also includes network diagrams, which allow students to make sense of the connections among things. And of course, it includes all the traditional mathematical diagrams, charts, etc., but enriched because now they can be interactive, respond to exploration. The next category is digital storytelling. We are very good at storytelling. We are particularly good at storytelling that uses concrete objects in the physical world and its counterpart when we use digital objects in the digital world. So we bring together text, image, audio, video to tell stories that can take the form of image assemblies, digital comics, digital videos, and perhaps even include interactivity and exploration as part of these narratives. And we can use these narratives to make better sense, more sense for our students. We can also use them to have students make better sense for themselves as they create digital storytelling narratives. Finally, educational gaming. I'm going to use a very simple definition of educational gaming here. And that very simple definition is to say that, okay, what we're going to do is simply say we're going to take either a visualization or a digital storytelling narrative, and we're going to add a stake. In other words, a way for a student to guide the visualization or to guide how the narrative progresses so that they can win. And that process of winning actually drives their knowledge, drives their exploration, so that they become interested, intrigued, challenged by how they win the game, and in doing so they have to explore more deeply that narrative and the knowledge it contains, or that visualization and the knowledge it represents. One more thing is needed. We need a focusing layer, and that focusing layer has to take the form of something that brings together the efforts of different teachers so that they better mesh with each other and with the work of an institution. And in that sense, I have found that using a list of 21st century principles, such as the one provided here by Mishra and Karelvik, can provide exactly this type of focus, exactly this type of meshing, so long as all the teachers in an institution agree on 2 key things. Number 1, that in any unit of instruction that they design using technology, they will incorporate at least 2 or more of these principles as explicit design principles for what they do. And number 2, that throughout the course of a year's instruction, they will try to visit all of these principles in different combinations. Now, not all 9 of the principles you see here need to be in a single unit of instruction, but over the course of a year, you expect that all 9 will have been represented to varying degrees in various units. If you have those 2 elements, then you have the necessary conditions for teachers to mesh their work together and for the institution to be transformed not just at the level of the individual classroom, but at the level of teaching practice as a whole. So, that's it. I hope that this brief introduction has provided you with a suitable framework for the work you're about to start with the excellent team at Lynn. I hope to be able to see you all in person soon. Until then, best of luck with all your projects. Thank you.